This is me RJ here and I welcome you to my channel Mr. Teeth, where your dental concept get dissected. So this is our part 6 video of the dental cement series, and in this video we will be discussing the zinc polycarboxylate cement. Okay, so this topic is a bit smaller than other those topic that I discussed in this dental cement series. Okay, so without delaying much, let's start today's topic. So as I have written here, in 1968 Smith developed it. Okay, so in 1968 zinc polycarboxylate cement was developed. Okay, so ADA number is 61. So ADA number of the zinc polycarboxylate cement is 61, and the phosphoric acid of the zinc phosphate was substituted with the polyacrylic acid. Okay, so how the invention of the zinc polycarboxylate cement happens is that, okay, so at that time phosphoric acid that is present in the zinc phosphate was substituted, okay, was replaced by the zinc polyacrylic acid. Okay, sorry, polyacrylic acid replaced the phosphoric acid of the zinc phosphate and formed zinc polycarboxylate cement. So you should remember this. After that, it was the first cement, okay, that is to be invented, okay, in order to that adhere to the tooth structure. Okay, so it was the first cement that adhered to the tooth structure. Similarly, after that, okay, in application section, so zinc polycarboxylate cement, okay, so it can be used as for the luting agent. Okay, so for the luting, the permanent restoration. Similarly, it can also be used as a basis and the liners, and for the cementation of the orthodontic bands and the root canal filling material. After that, it is available, okay, so in which forms they are available? Okay, so they are available in powder and liquid form. Okay, so powder and liquid system is also there, and water settable cement. Okay, so this water settable cement I have discussed properly in the GIC video. Okay, so glass ionomer cement video I have discussed properly about the water settable cement. So similar the concept is also here. Okay, so what we do is poly acid that is freeze dried, okay, that is added to the powder, and after that, okay, in liquid we take the water, and in glass ionomer cement we used to take water plus itaconic acid. Okay, but here we take the water and poly acid that is freeze dried and added to the powder, and they are mixed, okay, and they form the solution of the liquid acid. So you can watch that video once again, okay, so that your concept would be clear. After that, it is also available in the pre-capsulated form. So there is a pre-proportioned powder and liquid, okay, present in the capsule separated by a septum. Okay, so in powder liquid system, water settable cement, and pre-capsulated form, these three form zinc polycarboxylate cement are available. After that, I have mentioned here the commercial names of the zinc polycarboxylate cement. Okay, so they are not so important, just you can see once. Okay, so polyaf or dense ply, okay, and in high bond polycarboxylate, sofu, also we call sofu. Okay, so sofu and dense ply are the commercial name of this polyaf or high bond polycarboxylate. Okay, so they are not important, just you can see once again. Okay, once. Okay, so in composition section, so we have powder and in liquid. Okay, so in powder the ingredients that are present is the zinc oxide, which is the major ingredient. Okay, so it is a basic ingredient. Okay, after that, magnesium oxide, which is similar to that of the zinc oxide, and it is a principal modifier here. Okay, so they can ask you in the viva what is the function of magnesium oxide in the powder of the zinc polycarboxylate. So it is a principal modifier, and it aids in the sintering. Okay, so sintering means heating any constituent. Okay, so the ingredients are heated at the larger temperature, okay, above 1000 degrees Celsius. So that is called sintering. And oxides of the bismuth and aluminiums are present in this powder, and they are in a small amount. Similarly, stannous fluoride is also present there in order to increase the strength and also imparting the anti-carcinogenicity that modifies the setting time. Okay, so stannous fluoride means as it contains the fluoride, so it gives the anti-carcinogenic property to the cement. Similarly, it increases the strength and also modifies the setting time. After that, in a liquid form, okay, so we have aqueous solution of the polyacrylic acid, or copolymer of the acrylic acid, itaconic, malic, and the tricarbonylic acid. So it is quite similar to that of the GIC. Okay, so aqueous solution of the polyacrylic acid, or we can say copolymer of the acrylic acid. Okay, and acrylic acid are the itaconic, malic, or the tricarbonylic acid. And in previous video I have mentioned the mnemonic, that is TIM. Okay, so TIM is the mnemonic here. Okay, so tricarbonylic acid, itaconic acid, and the malic acid. So just remember this: zinc oxide, magnesium oxide, bismuth, and stannous fluoride. Okay, so just don't miss this stannous fluoride. Okay, so it is very important here. Okay, as it is imparting the anti-carcinogenicity property. After that, in a setting reaction, okay, so setting time is 7 to 9 minutes. Okay, setting time is 7 to 9 minutes, and it is a bit similar to that of the previous cements. So here, when we mix the powder and the liquid, acid attacks the surface of the glass particle, and after attacking, there is a release of the zinc, magnesium, tin. Okay, so tin ions are released in the solution. Okay, so just you should have to remember is that, okay, in every setting reaction of every cement, okay, just you should remember those ions. Okay, so those ions are specific for the different cements, so that you should remember those ions. So I have written in green here. Okay, so zinc, magnesium and the tin. Okay, zinc, magnesium and the tin. And iron binds to the polymer chain via the carboxylic group and cross-linking region. So it is a bit similar to that of the GIC, as I have discussed in the GIC. As the acid attacks the glass particles, okay, so there is a release of the ions like calcium, aluminium. Okay, so the calcium used to form the cross-linking, and later aluminium also formed the cross-linking, similar like that. Okay, here also after the releasing of this zinc, magnesium and the tin, okay, so they binds with the polymer chain. Okay, so they binds with the polymer chains. Okay, so the polymer chains are present in the liquid, so they bind to the polymer chain and form the cross linkings. Okay, and those cross linking form the set marks. Okay, so there is a finally formation of the set marks, a bit similar to that of the GIC. So I have drawn the set mass. Okay, set structure of the zinc polycarboxylate cement. So we have unreacted glass particle here, and it is present in the matrix of the zinc polyacrylate amorphous gel matrix. Okay, so you should remember this zinc polyacrylate amorphous gel matrix is a matrix present here. Okay, so remember this. After that, after completing this setting reaction, okay, we can proceed towards the properties. So in the properties we have mechanical properties. So in mechanical properties, the compressive strength, it is inferior to the zinc phosphate. Okay, so mainly we do compare zinc polycarboxylate with the zinc phosphate. Okay, because as I have mentioned earlier, the phosphoric acid of the zinc phosphate is replaced by the by the acid. Okay, that is a polyacrylic acid. Okay, so that we just compare the properties of those cement. Okay, so we just compare these properties of zinc polycarboxylate with that of the properties of the zinc phosphate. And okay, so here compressive strength, it is inferior. Okay, so you should remember this, sometimes they can ask. And the range is from 55 to 67 MPa, and ISO, okay, recommends minimum of the 50 MPa for this cement. Okay, after that tensile strength, so it is 3.6 to the 6.3 MPa, and it is slightly higher than the zinc phosphate. After that, in strength depends upon the powder to liquid ratio, molecular weight of the polyacrylic acid and viscosity of the liquid. So these are three factors, okay, on which the strength of the zinc polycarboxylate depends upon. Okay, so this is a powder to liquid ratio. Okay, so powder to liquid ratio, molecular weight of the polyacrylic acid and the viscosity of the liquid. After that, in the solubility and the disintegration section, so it is slightly more soluble than the zinc phosphate, and which is 0.6% by weight. Okay, so it is a slightly more soluble than the zinc phosphate. Okay, after that, it is more soluble in the organic acid like the lactic acids. Okay, and similarly the low powder to liquid ratio, if there is presence of the low powder to liquid ratio, it will cause the higher solubility. So just remember those points. Low powder to liquid ratio would cause the higher solubility of the zinc polycarboxylate, and it was similar in other cement too. So just relate those things. The biocompatibility, so it is a mild pulper response is present there. pH of the liquid is 1 to 1.7. Similarly, freshly mixed liquid, the pH is 3 to 4. Similarly, after 24 hours, the pH range is from 5 to 6. So okay, so as we can see here, the pH, okay, it is proceeding towards the pH number 7. Okay, pH 7. Okay, it is being neutralized so rapidly. Okay, so that is a main important point you should learn from this biocompatibility. Okay, so the pH of the zinc polycarboxylate would be rapidly neutralized, okay, in comparison to that of the zinc phosphate. Okay, so that zinc phosphate have the moderate pulpal response, but here it is a mild pulpal response. That is the advantage of the zinc polycarboxylate. The pH of the zinc polycarboxylate is neutralized rapidly. So as I have written here, it is less irritant than the zinc phosphate because the pH rises more rapidly and due to the high molecular. Okay, so they both points are very important. Okay, I am just telling those points, repeating those points, okay, many times, so you can remember this. It is a less irritant than the zinc phosphate, okay, because the pH rises more rapidly, and another point is due to the high molecular weight, it doesn't penetrate the dentinal tubules. Okay, they can ask you several times this question, why zinc polycarboxylate is more biocompatible than the zinc phosphate, then you should tell those points. After that, in addition, okay, so in addition, as I have mentioned here, okay, so the polyacrylic acid reacts with the calcium ions on the surface of the enamel or the dentine via the carboxyl group, thereby adhering chemically to the tooth structure. So it is similar with that of the GIC. Okay, if you have not seen the GIC video, so go and first watch the GIC video. There I have discussed this in detail. Okay, and here it is also similar. As in the enamel and dentine, there is a calcium. Okay, so calcium, other minerals are also present there. Okay, so the calcium, okay, of this enamel or dentine would cross link with the carboxyl group, okay, carboxyl group of the liquid of the cement, so that there is a presence of the addition. The bond strength to the enamel is 3.4 to the 13 MPa, and the bond strength to the dentine is this much. Okay, so I have also discussed with this point, okay, why the bond strength of the enamel is more than that of the dentine, okay, in the GIC video. So go and watch that. After that, the factors affecting it, okay, so what are the factors that would affect this addition? Okay, so the clean and dry tooth should be there. Okay, so that improves the bonding, and presence of saliva would decrease the bond strength. Okay, it is simple. After, if there will be presence of any kind of other foreign particles, then it would decrease the strength of the cement. So you should remember this. After that, it do not adhere to the gold or the porcelain. Okay, so you can remember this. Gold and the porcelain, it do not adhere. And addition to the stainless steel is excellent. Okay, so how to remember this? Okay, how I remembered this is, okay, so when you manipulate, okay, so in manipulation section I will be telling, okay, so we use stainless spatula, okay, stainless steel spatula, okay, so for the cement mixing. So at that time, okay, when you mix, okay, so the cement get adhered to the steel. Okay, so you can remember from that, okay, thinking that, okay, so addition to the stainless steel is excellent, but the addition to the gold and the porcelain is bad. Okay, so it doesn't adhere to the gold and the porcelain. And similarly, there is a better addition to the smooth surfaces than the rough surfaces. Okay, so in smooth surfaces there is a better addition. After that, in optically it is very opaque. Okay, so it is a radio opaque, very opaque due to the presence of the zinc oxide. Okay, so zinc oxide give its opacity. Okay, after that, it is a thermal insulator. So it is the advantage of this zinc polycarboxylate. Okay, zinc thermal insulator, anti-corrosive properties is also present there, but it is limited when compared to that of the glass ionomer cement. So glass ionomer cement is a gold. Okay, so it is a gold for the dentistry, but okay, in comparison to that glass ionomer cement, it is a little bit less anti-cariogenic. Okay. After that, in manipulation section of the zinc polycarboxylate, so first what we do is conditioning. Okay, that we did in zinc glass ionomer cement too. So in conditioning, we used to etch the tooth. Okay, etchant is applied on the tooth structure. The etchant contain 10% polyacrylic acid or 1 to 3% hydrogen peroxide. Okay, and after this is applied for 10 to 15 seconds, and after that the water rinse. Okay, it is rinsed by the water. Okay, and it is okay, so there will be appearance of the frosty. Okay, frosty appearance will be present there. Okay, that signifies that it can bond now better. After that, in proportioning section, okay, so 1.5 so is to 1. Okay, so it is a powder to liquid ratio by the weight in proportioning. Okay, so how much quantity we would take during the manipulation is this. Okay, 1.5 is to 1. So it is a general proportion present, but during manipulation we should take the proportion of the manufacturer. Okay, so what the manufacturer is trying to tell us. So according to the manufacturer instruction, we used to take that amount of the powder and the liquid. Okay, now after that, in the procedure, powder and liquid are dispensed on the glass slab, and just prior to the mixing, liquid is dispensed, otherwise its viscosity increase. Okay, so it is similar with that of the previous cements, and powder is added in the bulk. Okay, so powder is added in the bulk, so we do not add in little increments. Okay, so here is powder is added in the bulk. Okay, as we did in the zinc phosphate. Okay, so we divide the powder into 6 to 8 increments. Okay, and there I have given the proper ratio also. Okay, how in which ratio we should divide the increments of the zinc phosphate. Similarly, the mixing time, it is 30 to 60 seconds, and the working time, it is 2.5 minutes. The mix is ideal if the glossy appearance is present there. If there is loss of glossiness or the loss of luster is present there, okay, then it would indicate that setting reaction has progressed to the extent that proper wetting of the tooth structure is no longer possible. Okay, so it would indicate such things. So the glossiness, the lusterness should be present on the cement after the manipulation. So the advantage and the disadvantage. Okay, so I have just written 2 points here and 2 points here. So it is less irritating the pulp. Okay, so as I mentioned previously, why it is less irritating to the pulp. Okay, so there are 2 reasons. One, the pH rises rapidly, and another, it has the larger molecular weight and the size is also larger, so that it doesn't penetrate the dentinal tubules. And another point is chemical bond with the tooth structure. So it chemically bond with the tooth structure. So it is a first cement that was adhering to the tooth. So it is non anti-carcinogenic, okay, not anti-carcinogenic, but it is not proper, okay, disadvantage of this. It is a little bit anti-carcinogenic, okay, but in comparison to the zinc glass ionomer cement, it is less anti-carcinogenic. So that you can just say here it is less anti-carcinogenic in comparison to that of the glass ionomer cement. So that will be better term, okay, okay, less anti-carcinogenic than GIC, okay. So this will be better term here, and better options are available. So if we have better option, then why not to prefer those options and using this zinc polycarboxylate, okay. So this was a short video, okay. So in this video I have tried to incorporate all those important points, and those important points are more than enough for the university level examinations, okay, and also for your viva exam. So stay tuned, okay. For today this much, okay. So if you love this video, please to like, subscribe and share with your batchmate, because making those video takes a lot more effort, okay. So I will catch you in the next video. Till then, stay happy, healthy and study hard. Tata, bye bye, thank you.